Okay, so we're getting into our probability unit, and hopefully you guys are already working on your simulation that's due tomorrow, so don't forget about that. Don't forget about your simulation due tomorrow. Don't forget to do it, because that is a quiz grade, so don't turn it in late. We're going to take it off. So, probabilities. We're going to go over some rules of probabilities. How do you calculate these things? Some of this you may already know, some of it you may not. It may have been a while for some of these things. So we're just going to put it all together. So we're going to start up here with how many outcomes. So when we talk about the list of all possible outcomes, that is our sample space. So the sample space is the set of all possible outcomes. So this could be something like, let's say you're flipping a coin, and you're going to flip the coin twice. You could get heads, 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 tails, tails, heads, or tails, tails. That is your sample space. It's what are the possible things that could happen. So you want to be able to list those out. It is not unusual for this to be asked as part of an AP question. So if you're doing a free response, this may be part A. Tell me the sample space for this thing that we're asking you to do, and then they may ask you to do a probability with it in part B or C. So you need to be able to write out what are all the things that could be possible. Okay? And on these, the order that they happen matters. So listing tails, heads is different than listing heads, tails. So you want to list both. Okay? So, so for example, flipping a coin twice, we could get heads, 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 tails, tails, heads, or tails, tails. So you want to list all the possible things that could happen. For fundamental counting rules, this is where you're given options and you want to know how many different combinations you have. So this is something where a lot of times whenever you go to like restaurants or fast food places, they advertise, we have this many combinations of drinks or this many combinations or whatever. This is what they're using. It's all the different options you have available for each choice you can make. So to do this, to get the total number of possibilities, multiply the number of options for each choice. Okay, so we're going to multiply together the number of options for each choice. So, for example, let's say we are, you're ordering a sandwich at a fast food place, okay? We have options for the type of meat you want. Let's say your options are turkey, beef, or chicken. Okay, so we have 3 options for the meat. We could have maybe 2 kinds of cheese, American or Swiss. And then maybe types of bread. Hoagie roll, 3 options for that. So when you go to order this, you're going to have 3 options for meat, 2 options for the cheese, and then 3 options for the type of bread. So to figure out how many total different types of sandwiches could you make, you would just do the 3 times the 2 for cheese times the 3 for the types of bread. So we would have 18 options. That is our fundamental counting rule. This is something that's used fairly often. You see this come up even with ACT, those kinds of things. How many different ways can we build this sandwich? How many different ways can we make a pizza? How many different things? And you'll see these put together. Sometimes you'll see it as putting together an outfit. You have 3 different shirts, 4 different pairs of pants, 2 different shoes. Which ones do you want to wear? How many different outfits can you make? So this is something that's used quite often for that type of thing. So you just multiply the number of options for each choice, and that gives you the number of possibilities. Okay. Questions on either part of that? Okay. Look at basic rules. Okay. In order to have a valid distribution, for any event A, we want the probability of A has to be between 0 and 1 inclusive of those values. We talked about this a little bit before. If the probability is 0, what does that mean? Yeah, it's not ever going to happen. If the probability is 1, what does that mean? It's always going to happen. So it's sometime, somewhere between those. It's either always going to happen, never going to happen, or somewhere in between. Okay? So that's, for any event A, it has to be between 0 and 1 inclusive. The sum of the probabilities of all the outcomes. So if we take the whole sample space, calculate the probability of each thing happening, the sum of all of those in the sample space must be 1. If it's not 1, we left out something in our sample space. If we got something that's smaller than 1, we left something out. If we get something bigger, then we made a calculation error. So the sum of those must always be 1. So, we want to know, is this possible? So we're wanting to check, is each probability between 0 and 1 inclusive, and does the sum always add up to 1? So here, excuse me, each probability individually is between 0 and 1. If we add these up, we get something that's equal to 1. So this one is yes. That one is a possible sample space of probability. On part B, we have each value individually is between 0 and 1. If we add them all together, do we get 1? Yes, so this one works. What about C? What's the problem? It's greater than 1. So this would be no, because the sum is greater than 1. What about D? Yeah, that was okay. What about E? What's the problem here? Yeah, this one is not between 0 and 1. So we have a problem there. So, no, can't have a negative probability. So this is something that is a common thing to see, especially in a multiple choice. They may give you these options and say which one of these is not a possible probability. And so they would give you some options, and you have to know which one is okay and which one is not okay. So each individual probability between 0 and 1, the sum of all of them together has to equal 1. Questions? Okay. We're going to go down here to complement rule. Okay, so definition of complement. So a complement is the set of all outcomes that are not in event A. So, for instance, example of this one. Let's say we're rolling a die. And event A, I'm going to say, is getting a 4. Okay? So the complement to A would be getting any number that's not a 4. So getting a 1, 2, 3, 5, or 6. That is the complement of event A. Okay, so it's everything that's not a part of what we're looking for. Okay? Sometimes event A will be multiple options, so it's everything that's not a part of that. So you want to look at your sample space, all the possible things, look at the ones that are in A, and then look at the ones that are not, and that's going to be your complement. So the notation, there are several different ways this can be notated. Sometimes you'll see it like that with a little tilde in front of the A, which is not A. Or sometimes it will be A with a C, like it looks like an exclamation C. So it's A complement. That's how that would be read. Sometimes it's A with that little prime mark. So that's the complement of A. And sometimes they just write not A. So you just need to be able to recognize any one of those means the complement. Okay, so any one of those notations could be used on an AP question, so you need to be familiar with all 4 of those. So the complement rule, this is one that we use often when we're calculating a probability. So the probability of an event occurring is 1 minus the probability of it not occurring. So in other words, the probability of A is 1 minus the probability of not A. And conversely, the probability of not A is 1 minus the probability of A. So you can find either the complement or the probability of A using this complement rule. Often it's easier to calculate the probability of A using this, especially if we're looking at multiple things involved. Sometimes it's easier to find just the ones that don't fit it and subtract from one than to find all of the different options that fit the event A. So either way, you'll get the same answer. It's just sometimes it's easier to use the complement rule. Disjoint or independent events. So we need to define some of these things because we're going to use these terms in getting these addition and multiplication rules. So, disjoint events. Sometimes you'll see these called mutually exclusive. Those two terms mean the same thing. So if you're talking about disjoint or you're talking about mutually exclusive, it's the same. Okay? They use these terms interchangeably. This just means the two events we'll call them A and B. Cannot occur at the same time. So think of this as far as things like your age. You can't be two different ages at the same time. Okay? If you think of it, are you an adult or are you a minor? Have you had your 18th birthday, you're an adult. If you haven't, you're a minor. You can't be both. Those are mutually exclusive events. You're one or the other. Okay, you can't be both. So those would be considered disjoint. Independent events are where knowledge of event A does not affect the probability of event B. Saying if I know what happened with the first thing that I was wanting to happen, that doesn't change the outcome of the next one. Think of it, if I'm going to flip a coin and then I'm going to roll the dice. The outcome of the coin flip has no bearing on what is going to happen with the dice. It doesn't change that probability of getting a 3. So one event independent of the other one has no effect on each other. If you're talking about, let's say you are selecting volunteers out of a classroom or something, okay? So I'm going to select 5 people and they're going to get extra credit points just because they got selected. Once I select one, that person has been selected, so the second person, the probability of being selected went up a little bit because there's less people to pick from. By the time I get to the 5th person, their probability of being selected on the 5th draw is higher than it was on the 1st draw. Does that make sense? Because I've already chosen some people. So that would not be independent because the probability changes each time one was selected. The probability of getting selected next is different. Okay? So dependent, independent, does the probability change each time? A lot of times you'll see with replacement and without replacement. If it's with replacement, then the probability stays the same every time. Without replacement, it changes. So that replacement idea is something that will clue you into, is it independent or dependent? So, additional. So here, the addition rule for disjoint events says if we're looking at the probability of A or B. When you see two options and it's an or, that tells you you're doing addition. So we would just do the probability of A plus probability of B. So if it's A or B, just find the probability of each one and add them together. Yes? So this is if they are disjoint, if they couldn't both happen at the same time. So here we're looking at 2 red marbles, 1 green marble, 1 yellow marble in a bag. So how many marbles altogether? 4 marbles. One marble is chosen. Find the probability that each event will occur. So we want a red. So here we see 2 red out of the 4, or 1/2. Now, when you are doing these, you have to show this fraction. You don't have to necessarily reduce it, but you do have to show where this number came from. Don't just write 0.5. It's better to write it as a fraction than a decimal, but if you write a fraction and then convert it to a decimal, that's fine. But you still have to have the fraction to show your work. So a yellow marble, there's 1 of those out of the 4 marbles, so we have a 1 in 4 chance. When we look at a red or a green, so we have 2 out of 4 are red. Or means add the green, there's 1 out of 4 that are green. So that gives me a 3 in 4 chance of getting a red or a green. If we're talking about a yellow or a green, there's 1 yellow and 1 green. So 1 in 4 for each. And since it's an or, we add them together. So we get a 2 in 4 or 1/2. Is this making sense? If we say not a green, this is where we can use our complement rule. Because we know green is 1/4. If we want not green, we could just do 1 minus 1/4. Or we can add together all the other options. We could have done red plus yellow. We'll get the same thing. What's the probability of a blue marble? 0. No blues. Okay. Now, the multiplication rule. So, addition rule, we add when it says or. Multiplication rule, we multiply when it says and. We just multiply the 2 probabilities when it's an and. Here we have a bag that contains 4 red, 5 white, and 3 blue marbles. So that's 12 marbles altogether. Suppose you chose a marble from the bag, then replace it, and then choose another. Find the probability of doing each one. So we want white both times. There are 5 white, so we have 5 out of 12. For the first draw, and then we put that one back, we have 5 out of 12 again for the second draw. So that would be 25 out of 144. When we talk about blue both times, we have 3 blue marbles, so we have 3 out of 12. Put that one back, we have 3 out of 12 again. So we have 9 out of 144. or if you wanted to simplify, 1 over 16. And again, you don't necessarily have to simplify the fraction. If you have the 9 over 144, you're good. Probability of red both times. We have 4 that are red, so 4 out of 12. Okay, so what are we going to do here? Same color both times. They could be both red, both blue, or both white. So we're going to take these probabilities and add them together because it's this or this or this. So I'm going to go back to where they were all over 144 to make it easier to add. So again, make sure you're showing your work. Don't just write down the answer. You have to show how you got the answer. So we want probability of red, then white. Okay, so red, we've got 4 out of 12. And then we want to get white, which was 5 out of 12. White then red, we're just changing the order of multiplication because we're changing the order that we would get these. So we get the same numbers, just we reverse it. So it would be 5 out of 12 and 4 out of 12. If we do white then blue, we do red, it's 4 out of 12. Green, don't have any. So that probability is 0. Can't get that. So make sure, like I say, when you're doing these, make sure you show how you get the answers. Don't just write down the number that's your final answer. I know a lot of these you can just do in your head, but still show your work. Okay, so that is going on page 110, and then page 111, this is your problem set. So all of these are using the information over here to find probabilities, and then you just fill in the letter above the number that matches that answer. So both sides, front and back. So I'm going to give you the rest of the time to get your problem set done. If anyone has a simulation project and wants me to look at it to give you some feedback, feel free to let me do that.